Hello and welcome to this TGA digital video on how to create a team color shader using ShaderFX in Maya. With this team color shader, you will be able to use Vertex Color painting to mask out areas on the model where you want to apply a team color to. If you're not familiar with working with ShaderFX, check out the link below in the description for a video tutorial where I show you how to get started with ShaderFX. So let's get started with this shader. In this lesson, we'll be creating a team color shader where we can use vertex colors to define areas on the model where we want to apply a team color. And the team color will have that as a color swatch in the shader attributes so that we can change it to whatever color we like. Now, I've got this nice looking example model here from one of my talented students, Joachim Hegström. And I've got a color texture as well to go along with it. So without further ado, let's open up ShaderFX and get started. So this is just a new ShaderFX shader that I created, and I have the standard traditional game surface shader. But since I want to create my own shader solution from scratch, I'll just go ahead and choose these and delete them. So I'll start off with using the baseline shader group, which we created in an earlier lesson. And I'll show you the texture to begin with. So I'll create a texture map, this one, and I'll load the texture, which is this one. And you can see the texture here as well. You've got 3 different previews in the node, which you can enable with this button. So I've got the big one, just the standard icon, and a small preview, and I can cycle between these 3 by clicking here. So I think I'll leave it like this, and I'll just go ahead and connect this one here and show you what it looks like. So there's the texture applied to the model. I think I'll just use, this is kind of a hack if you will, but I'll just use the convert to linear space just to make it a tad bit darker, because I think it gives more contrast to also have the dark areas. I'm not sure what the intended render engine was for this texture to begin with. So you don't have to do this step, it's just a hack if you will for me to get it darker here. So that's the texture, and one essential node to this network is being able to access the model's vertex colors in the shader. And you do that with a node called Vertex Color down here under Input Commons. Don't confuse it with this Inputs Application one. They look quite similar if you create them like that. But it is the Vertex Color under Input Commons that we want, this one. Now the key to get this working is you have to tell this Vertex Color node the exact name of the Vertex Color set that the model has. So to begin with, I'll just make a vertex color set for this model. I don't have one yet, and I'll click the new button here. That is, if you're not familiar with it, you have it under mesh display and color set editor. In older versions of Maya, I think if I'm not mistaken, there's a menu under this menu set which is called polygons, is it not? And the menu is called color, I think, and you have the color set editor. So in the color set editor, I'll click the new button, and I can leave it at RGBA. We're actually just going to use one vertex color channel, so it doesn't really matter that much. I'll click apply and close, and with this new set, I'll select it and click rename, and I'll give it an appropriate name, which could be, for instance, team color mask, with a capital letter on each word, team color mask. And I'll go ahead and close this. So back to ShaderFX editor, and I'll choose here, color set name, team color mask. And make sure you get the name exactly the same. Now I should be able to access the vertex colors from this node. And I think by the default, when you create a vertex color set, which I just did, it's just pure black. So I'll probably just have a black color now, since I'm feeding the vertex color straight here into the shader. Yeah. And to just see if this works, we could go ahead and choose the Paint Vertex Color tool, and let's paint with a red value, for instance. and as you can see, I've now got the vertex colors fading into the shader solution. I'll just go ahead and fill it with black again. Right. So another crucial node that we'll be using is a lerp node, or a linear interpolate node. This one. It's often referred to as lerp, L-E-R-P, but it stands for linear interpolate. So what this actually does is it lets you take two values, this value, the first and the second, and then with the third value you can mix between the first and the second one, depending on what you feed into the mix. So just to get started, I'll create a color node, which is under values, color. And this gives me a swatch where I can pick a color, so blue for instance. And I want to choose between using the texture and this here uniform blue color. And I want to use the red channel, for instance. You could pick green, blue, or alpha for that matter, but the red channel from the vertex color into the mix. And then that result I want to use here. Now, as you can see, I used the color outputs here, and I did that for a reason. I could have taken the RGBA here and I would get the float 4 here, the pink output, and I could just connect it directly. Now I can't, since this is a float 3 and this one wants a float 4. And the reason for this is I've previously had issues where the lerp node, if I would take the RGBA output of a lerp node and connect it directly here, I'd get some strange results. And I was able to track it down to something to do with the alpha channel of the output. And since I'm not interested in the alpha channel in this case, I just want the RGB, I think I'll construct my own RGBA over here and control the alpha with a uniform value. And one way to do that is using the vector construct. The vector construct lets me take several different inputs and output them as a combined data stream. So I could, for instance, take a red, green and blue value from different areas, connect them to X, Y, Z here, and then I'd have them combined into one float 3 data stream. So I'll take this here RGB, connect it into the X, Y, Z, and then I'll take the float 4 from here and connect there. Now this one only gives us 3 inputs RGB, and the fourth one, the alpha value, is, or actually it's called W here, it's the same thing. It's a uniform value of 1 all over the model. Now this is not going to give me any issues, hopefully not. So if we were to look at the model now, it's going to look just like the texture. And that is because the red channel here has a value of 0.0 all over. So it's going to pick this value and output it over here. Once we start painting in the red channel of the vertex color and paint it white, for instance, in certain areas, those certain areas are going to get this value instead, and the black areas are going to get this value when it's fed through the output here. So we should be able to select the model. I'll choose the last tool I used here, the paint tool. I want to make sure that I add a value of 1 in the red channel. Green and blue doesn't matter. And I can use the operation replace, for instance. And I'll just start painting. So once I paint here, you can see that I get the blue color. So it seems that the lerp node is doing what we expected it to. It's choosing between 2 different inputs. Now you could go ahead and say that, well, we've got team color working now. And yeah, that's true, but I want to make it look a bit more nice than this. What I want is, I want to tint the color blue. That is, I want to keep the nice looking seams here and the variation in the color texture. I want to keep that. I just want to tint it blue instead. And one way to do that is to take this texture and desaturate it and then multiply by the team color. And to desaturate this texture, you can do it in at least 2 different ways that I know of. You can use the prefabricated desaturate node, or group actually, or you could do the desaturation yourself. And I think I'll do it myself because then I'll get to show you another feature in ShaderFX. And the way you desaturate, it's actually, you want to get an average value. And to get an average value, you have to add together the red, green and blue channel. You add them together and then you divide by 3, since we have 3 different values. If I had 4 values I wanted an average, I divide by 4, etc. So I can connect the red value here and then the green value. But I can't continue to add the blue value here, at least not yet, because it only takes 2 inputs. But on some nodes you can actually click this checkbox called Support Multiple Connections, which will change the second value here into a square instead, indicating that it will take several inputs into the same input here. So now I'm adding together all of these 3 values, and then I want to divide by 3. So I'll choose a divide node and place it over here. I'll take this output value from the add, and then I'll actually set this value to 3. And you can do that in 2 different ways. You could either create a float, which is a constant value with a decimal, and type 3 in here and connect it. Or you could click on the actual value here and then type in 3 here, like so. Both of those give the same results. So I'll stick to this one. Now if we check the little preview here, you'll see that I have the same texture as this one, but it's desaturated. And that's exactly what I was after. So next step is to multiply this result with the theme color down here. So I'll go fetch me a multiply node, place it over here, take this one and this one. Now I'll just move these to the left a bit because I want the connections to flow to the right. So I needed to create some space here. We can just view the results and see that we have the same result multiplied by blue. So now I can go ahead and replace this uniform blue value going into the second value here with this one, like so. And I could select these 4 nodes and move them down here as well, which would be easier to see what's going on with the different connections. Like so perhaps. Yeah. Let's see. Now we have the blue value, but we still have the variation of luminance from the color texture, which looks more appealing to me, because then I can still have variation within an area. Right. So another thing I want to handle is this fall off here. Now this might be a matter of choice, or not a matter of choice. It might be subjective depending on how you want it to work. I wouldn't say that it's right or wrong, or to do it either way, but I want it to just be blue along this line, and then I don't want this fall off here. And there are a few different ways you could do this. What it has to do with is the vertex color, because when I'm painting my vertex color, I was painting with white in the red channel, and as I'm painting white on these pixels and these are black, they're going to interpolate in between. That is, since I've only got so many vertex points, I can still get a smooth transition in between them. So it's going to change from white to black here linearly. And I want it to not have this linear interpolation in between here. So the way I'm going to do this is just take the linearly interpolated value here and make sure that I make it more sharp, if you will. Now, at least in theory, you could do this in several different ways here. I've tried a few of them, like using a floor node or a step node, or even casting to an integer value, but I've gotten some weird results here, which I'm afraid I can't explain them. But one way I did get it working is by using a comparison node. So for those of you who are thinking performance-wise, this is not the most performance-oriented way of doing it, but ShaderFX would throw me weird results otherwise. So that's my reasoning for using this method. So I'm going to be using a comparison node, and I'll need I think I need a float node as well. Yeah, you can't type in specific values on this node. On several nodes you can, like I did with the divide. You could click here and type in a value. You can't with this one. So I'll be comparing the red channel with a float value, this one. And I want the float value to be 0. There you go. And I want to ask, is the red channel larger than 0? And therefore I choose this one and choose the operator, which is this one, larger than. That should give me the results I want, because the comparison node is going to give me a bool data type, and the bool is either true or false, or if you will, 0 or 1. So this doesn't have anything in between. So this will make sure that my linear interpolation will not have that transition. I'll just get a sharp edge. Or I could, if I wanted to, I could also. I think I prefer this way. You could do it several different other ways. You could check if it's exactly 1, or depending on how you want the sharp edge, where you want it to end up. So this should work fine. I should now be able to use this bool value in the mix here instead. So if I disconnect this one, I should be able to connect it here. There you go. Now I have this sharp edge here instead. And the reason for me wanting it to be this way is because this is probably, I wouldn't say this is the most ideal model to show this off on, because I don't have areas like the shirt here that align perfectly with where the pixel or the edges are. But imagine if I had like a Space Marine character or some sport player with a helmet or something. I would want to shade the entire parts of the model, and I wouldn't want them to have a soft blending into the other areas. I wanted them to be either completely team color or not completely team color, and nothing in between. So this was the look I was after. So we've now gotten most of what we need working here. I think I will show you another nicety, another feature we could add. But at this point, we might consider exposing some of the values which we want to be able to change from outside of the shader network. So one thing we definitely want to be able to change is the texture, which texture we want to use. And to do that, I click the Expose as Material Input. And for textures, it's going to use the myTexture/unique name variable. It differs some from other nodes you might expose. So this name won't be the name that shows up in the attribute editor. So I'll go ahead and click here, and I'll call this my color texture. Color texture. Make sure you click this as Expose Material Input. Another thing we want to expose is the theme color. So this one you click Expose as Material Input, but on this one it's the name that's going to show up in the attribute editor. So I'll go ahead and call this theme color. And I think that should do it for now. Let's just minimize this, and I'll select my attribute editor, and you can see that my ShaderFX shader now has these two values exposed. So I can point at what texture to use, and I can also go ahead and try different theme colors on these areas. Right, so let's just try something, try painting some other part for example. So I think I'll revert to having, or actually I can do this in the paint interface. I'll once again go for a black color as base. So I'll flood with a black color. Then I'll go ahead and paint with red again to define which areas I want to be team color. And let's say that I want the pants to be team colored. Now I'm not going to do this super exact, but I'll try to do it fairly close. So something like that. And for the same reason I mentioned earlier, the texture parts don't exactly match up to where the vertices are, or I don't have edges going exactly along this part, so I can't get it exactly right. But imagine that you did design or create your model with this intention of using vertex colors. But I could at least try to get it a bit better by painting black again to remove this part. So, and if I wanted to, I could show this as well to see which vertices I'd want to paint on, for instance. So something along these lines, perhaps. I could actually perhaps remove these as well. Yeah, I think you get the picture. I'd remove these as well. Yeah, perhaps like so. I think I removed a bit too much over there. It's not super important, since that's not the thing I want to focus on in this video, but you know, as an artist, you find it hard to leave things not tweaked, if you will. Same with the boots here. Let's just go ahead and clean them up a bit as well. Since I'm trying to do this properly, why not? So I'll go ahead and paint like this. Yeah, maybe a bit too much. There we go. I'll remove these as well. Almost done here, bear with me, like so. So there's one other feature which I think I'm going to show you, which could be nice to add to this model, and that is the ability to make the area a bit brighter. Because as it is now, I have this really bright pink color going on here, but it translates to quite a dark pink here. And the reason for this is because the team color, the original color on the color texture was quite dark to begin with, so I can only tint it in other hues, if you will. I can't make it brighter, but I want to be able to add the ability to do that. And one way to do that is by let's see, by modifying the vertex color. No, hold on. To add in between the divide and the multiply here to, yeah, of course, to make this part brighter. So I've got my pants over here, I think, and I want to make them a bit brighter. So one way to do that, you could add a add operator here, but the add operator, I wouldn't call it ideal, because if I've got some variations in the brighter spectrum, the add would actually remove or if you will kill those variations if I added a lot of values, a high value, since I'm going to cap out at 1.0. So I prefer to use the power of operator, which is just called pow, this one. And if I connect the pow in between here, and I make sure that I add a value which is between 0.0 and 1.0 here, I can get it brighter without losing any of the variation, or not much of the variation, which has been hand painted by the artist here. So if I'll just show you how that works. If I connect a float value here and then connect that here, when the float value is 1, I won't get any difference. Let's see, there's my float value. But as I go to a lower value here, you can see that it gets a bit brighter. But I'm still able to see the variation here with the scratches or the folds and the seams and so on. So I want to use this as a way of letting the artist make this part brighter. And I think I'll just reverse it as well and call it brightness, because right now a value of 1.0 doesn't make it brighter, and as I go towards 0.0 it gets brighter. So calling that brightness is a bit confusing if you ask me, because a lower value would equal brighter end results. And one way to do that is to use the simple 1 minus node, or invert 1 minus. It's going to take my value and actually 1 minus my value. So if I have it at 1 as I do now, it's going to be 1 minus 1 equals 0. and if I had this one at, let's say, 0.7, I'd get 1 minus 0.7, I'd get 0.3. So it's going to invert the value around 0.5, if you will. So I'll connect that here, and now as I change this value, you'll see that a value of 0 gives me an unmodified results, and if I increase it, you'll see that it gets brighter. Now this can be nice to let the artist go from having these dark pants to having super bright colored ones instead. So I'll go ahead and expose this value as well, which with the expose as material input, and I'll call this team color brightness or brightening, for instance. Team color brightening. I think I named my other variables with expose variables with an underscore like that, so I want to try to keep it consistent. Yeah, there we go. So now I have that brightening as well, and I can choose different colors and get them bright. Let's say a yellow value if you want, like so. And that might be too dark of a yellow value, so I could add a bit of brightness as well. Yeah, and that's pretty much it. To recap what we've done here, and at this point I've already got it quite organized here, but you might have it a bit messy here, so I would take my time and just clean this up a bit. And the main thing here is to try to group them together if they're doing something, so you leave a bit of space in between here to make a difference between them. And I also usually want these connecting lines here to be fully visible, so they're not obscured by several nodes like this. Oh yeah, you can't undo those actions. Here we go. Right. Yep. So let's see. We've got our original texture, and we're making some changes to it so that we've got a user-defined team color value here, and we're taking a desaturated version. This one here's my desaturation of the original texture. We're modifying that desaturated version with a user variable for making it a bit brighter, as you can see. We're then multiplying our results by the team color value, which is also set by the user. I'm not sure why I get a red color here at the moment. I think it was because I did some undo before. Yeah, there we go. So now I get the desaturated brightened version multiplied by the yellow team color, which is set by the user, and I get the yellow variation or yellow tinted texture. Then I choose between using either this yellow tinted version or the original texture, this one. I choose between these two. And the thing that lets me choose which one ends up where is the red channel from the Vertex Color. And since I don't want any fall off between the areas which are team colored or not, I use this comparison node to make sure that if the value inside the red vertex channel is greater than 0, then I get a true from here. It's true or false, or 0 or 1 if you will. And it doesn't have any in between, and therefore I get this sharp edge here, which is the desired results I wanted for this lesson. So that pretty much sums up this lesson or doing team color. Please let us know what you thought about the video and what you want to see next. To see more, visit our website or follow us on Facebook and Twitter.